this lesson, we're going to determine the multiplicity of zeros of a polynomial function when given its graph or its equation in factored form. Multiplicity of a zero. Multiplicity of a zero. Now, the number of times a given factor appears in factored form of a polynomial is called the multiplicity. So if you have a function and it is in factored form, whatever the degree of that factored form is its multiplicity. Now, of course, when you have it in factored form, you have to solve for x. When you solve for x, that's going to be your zero or your root or solution of that factored form. Let's say, for example, here we're given this polynomial function, and notice it is in factored form. So it looks like we're going to have 3 roots or zeros or solutions. Now, to find its multiplicity, you're going to have to, if you have more than one factored form, in this case we have 3, we have to add them all up to find the sum. And then that will be the multiplicity of that polynomial. So with the first factored zero there, you don't see a number outside. When you don't see a number outside, it is understood to have a degree of 1. So the second factored form of the polynomial has a degree of 2. So 1 plus 2 so far, that gives me 3. Adding the last one is going to be a total of 4. So this is a 4th degree polynomial, and we would say that this polynomial has a multiplicity of 4. So again, looking at each of the factors individually, the first factor of x minus 6, if we solve that for x, there's a 0 at 6. And for its multiplicity, remember when you don't see anything outside, it is understood to be a 1. For the second factored form, our 0, if we solve for x, x would equal 1. So we're going to have a 0 at 1. The outside degree tells the multiplicity. This one had a multiplicity of 2. The third factored form, if we solve that for x, we're going to have a 0 at negative 2. Again, when you don't see anything on the outside, it is understood to have a multiplicity of 1. If we add up the sum of the multiplicities, that is going to give you the multiplicity of that polynomial function. And in this case, when you add up all those degrees, it adds up to 4. So this polynomial has a multiplicity of 4. Okay, so recall the multiplicity is going to tell us the degree of the polynomial. If we were to add all the multiplicities up, we would know what the degree of the polynomial is. So here we're asked what is the degree of this polynomial. So looking at the multiplicities, we have a multiplicity of 2, a multiplicity of 3, there the degree, and then the last one has a degree of 1. So if you were to add all those up, 2 plus 3 plus 1, that's going to give you a total of 6. So this is a 6th degree polynomial, which is an even degree. And recall with even degree, both ends, according to the end behavior, would be either facing upward or downward based on the leading coefficient. And as we can see here, our coefficient here is a positive, the leading coefficient. So yes, we have an even degree polynomial. Now, in terms of stating all of the multiplicities there. We have a multiplicity 2, 3, and 1. But the thing you need to know about multiplicity, it also tells you how the graph behavior is going to move in terms of the turns or the whether it crosses or touches, in other words, the graph. So we know that our zeros or our roots, recall that is the point where it touches the x-axis. So we can see here that when we solve for x equals 0, x equals 3, and x equals -1, those are going to be the 3 places where it touches the x-axis. And as you can see here, -1, 0, and at 3, that's where you have the zeros. But what you need to know about these multiplicities is they tell you some very important things. If the multiplicity is an odd number, it tells you that it is going to cross the x-axis at that point. So notice that for the 0 at 3, that's an odd number. And so notice at 3, it crosses through the x-axis. And also with the last 0 there of -1, it has a multiplicity of 1. That's an odd number. So notice at -1 where that 0 is, it also crosses the x-axis. But if the multiplicity is an even number, it is just going to touch the x-axis. It's not going to pass through it. So notice here with the 0 at 0 here on the outside, this particular root or solution is 0. And this is an even multiplicity. So at 0, it is going to touch. And notice here it touches. It does not cross. So anytime your multiplicity, the degree, if it's even, it is going to touch the x-axis. If it's odd, it will cross or pass through the x-axis. So that's some things that you can be able to determine just based on the multiplicities, that type of behavior, what that graph is going to do, whether at those zeros, whether it's going to touch at that point or whether it's going to cross. Here's another polynomial function. So let's find out what is the degree of that. And to find the degree, you have to add up all the multiplicities of those zeros. So the first one, you have a multiplicity of 2, a multiplicity of 1, and a multiplicity of 2. When you add all those, you have 5. So this is a 5th degree polynomial, which means this is an odd polynomial, and it's right in line with that known behavior of one end being up and one end being down. The other thing is that we want to find out where on this graph it crosses or touch. So looking at that first 0 here of that 0 of the root of 0, because when you solve for x, it equals 0. Since it has an even multiplicity, it is going to touch at 0, and yes, it does touch at that point. The other 0 or root that's at 2, it has an odd multiplicity, so it should pass through at 2, and as you can see, it passes through at 2. The last root or solution is x equals -3. It has an even multiplicity, which means it is going to touch at -3, and as you can see, it does touch at -3. So again, with multiplicities, it tells you a lot about how that graph is going to touch the x-axis. If the multiplicity is even, it is going to touch the x-axis. If the multiplicity of that root is odd, it will cross or pass through the x-axis at that point. And there you have it, multiplicity of a zero. Okay, everybody, I want to just make sure that we got this whole thing of multiplicity of the zero. If you can identify, well, what are the zeros or the solutions or what we call the roots. And then if you can tell me where it crosses and where it touches on the x-axis, and then what is the degree of the polynomial. And recall, to find the degree, all you have to do is just add up all the multiplicities, and that will give you the degree of the polynomial. So let's start with the first example there by identifying the zeros. In other words, what are the zeros, roots, or solutions? And all you have to do is simply solve for x. So when we solve for x here, we can see that for the first, x will equal -1. For the second parentheses there, x will equal 2. And for the third zero, x is going to equal 1. So our zeros are going to be at -1, 2, and 1. Where is it going to cross? So the cross, recall, that is the point where the multiplicity is an odd number. So 1 is an odd number, so we can see that it is going to cross at 1 and at -1. Touch is going to be the point where it's even, and so of the even, it is even at 2, so it's going to touch at 2. What is the degree of the polynomial? All you have to do is simply add up the multiplicities, 1 plus 2 plus 1. That's going to give you a total of 4, so that's a 4th degree polynomial. Let's go on to the second example. So where are our zeros are going to be? We're going to have a zero at, you guessed it, yes, when you solve for x, x equals -2, so we're going to have a zero at -2. And we're also going to have a zero at where? Yes, you got it, at 1. So -2 and 1 are your zeros. You only have 2 of them. Let's see whether they cross or touch. So where are they going to cross? Cross will be your odd multiplicities. There are no odd multiplicities, so it is not going to cross anywhere. It is going to touch at those 2 points because, recall, touch is the even multiplicity, so it touches at -1 and 1. And what is the degree of this polynomials? Well, when we add those multiplicities, 2 plus 2, that was also a 4th degree polynomial. Next, we have our zeros at where? Well, let's take a look at the first one, solving for x. X equals -1. Second one, x equals 1. The third one, x equals 2. So we're going to have 3 zeros, and those zeros are going to be again at -1, 1, and 2. Now, where is it going to cross the x-axis? Well, remember, cross is going to be your odd numbers. So our odd numbers, it's going to cross at all those points, because recall, when you don't see a multiplicity outside, it's understood to be a 1. So since all the multiplicities are odd, it's going to cross at all 3 points, which means it's not going to touch at any of those points. And what is the degree of that polynomial? Well, let's add those multiplicities there. We have 3 plus 1 plus 1 is a total of 5. So that is a 5th degree polynomial. You're doing great. One last one. Can you tell me what are the zeros of that last polynomial? Well, if you said for the first one, x equals 2, and for the second one, x equals 1, and for the third one, x equals -1, so we have 3 zeros at those points. You're absolutely correct. So we're on the x-axis. Is it going to cross? Well, we're looking for the odd numbers. Only one of them have an odd number, and that's at 1. So at 1, it is going to cross, and at the other 2 points, it is going to touch. And can you tell me what is the degree of that polynomial? Let's add up the multiplicities. 2 plus 1 plus 2. And that one also is a 5th degree polynomial. And there you have it, multiplicity of a zero.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.